So this for the lab 5. So we're using the same circuit we did in lab 4. So in this circuit, we have one resistor in series with one capacitor in parallel with one inductor. So exactly same as the circuit in lab 4, except the resistance of this resistor is 2 kilo ohm instead of 10 kilo ohm. The capacitor is still 15 nanofarad, and the inductor is still 92 millihenry, and its internal resistance is still 130 ohm. So we are connecting the input across one end of the resistor and the ground, connecting to one end of capacitor, one end of the inductor to the function generator. And then the first channel of the oscilloscope is connecting to the output of the circuit, which is crossing the capacitor and the inductor. The second channel of the oscilloscope is connected to the input, which is monitoring the signal from the input of the the input of the circuit, which is the output of the function generator. So the difference is the difference comparing to lab 4 is we set a sinusoidal wave instead of step function. So the sinusoidal wave right now has a 10 volts peak to peak amplitude and 500 hertz frequency. So the oscilloscope, the yellow sinusoidal wave shows the output of the circuit. The green shows the input of the circuit. And the last data shows the phase shift between the two sinusoidal waves. So what I'm going to do next is I'm going to write down the frequency of the sinusoidal wave from the function generator, then record the amplitude in terms of root mean square for both input and output, and also record what's the phase shift between the two sinusoidal waves between the input and output. I'm going to input these 3 data points together with the frequency in an Excel sheet. So that sheet will be uploaded to Nexus. Then I'm going to increase the frequency from 500 to 1000 to 1500 to 2000 to 2500 all the way to 10,000 with a step of 500 hertz. At each frequency point, I'm going to re-record the amplitude for both the input, the green curve, and output, the yellow curve, and the phase shift between the two curves. So then finally you will see an Excel file in the Nexus with 4 columns. One column for frequency, the second column for the amplitude of the input, the third column for the amplitude of the output, the third column for the phase shift between the two sinusoidal waves. Please pay attention for 2 things. One is for the phase shift, if it shows a minus 54 degree, it could be sometimes be showing on this model or oscilloscope as 306 degree. So in quadrant 3, so minus 50 is the same as 310. So sometimes what I recorded in the Excel is exactly same as what shown on the oscilloscope. But when you do the analysis, you need to make it consistent. Either all use minus 40, minus 50, minus 45, or all of them use 315, 310, 320. So I'm going to do it. Give you a quick idea. So what's going on here? So now I'm increasing to 1000 hertz. I'm going to record all these numbers. Then next one I'm going to do 1500, then all the way to 10,000 with a step of 500. So the Excel file will be in the Nexus, and the data point for the MATLAB saved data, you do not need them for this lab. So that's it for this lab 5 tutorial video. Thanks.